Okay, class, today we are talking about function rules. So we said that a relation is a function if, and only if, right, that x value doesn't repeat. So a function rule and function notation is only something that works for functions, right? Everything else we looked at on Friday was something that was a representation for a function and if it was just a relation. Okay, so the ordered pair, the table, the mapping, the graph. Okay, this is just going to work when we are talking about functions. That's all we're looking at here. Okay, and it's sort of a way for us to hold a bunch of values without having to write them all down. So let's say it cost $2 for a pair of socks. Clearly I'm creative right now. Right? If I wrote a function rule for it, I could then get the value whether I buy 2 socks, 10 socks, 100 socks, 1,000,000 socks, without having to write down an ordered pair for every situation between 1 and 1,000,000. Okay, so a function rule is something that simply gives us a place for an input value, and then it will give us an output value. Now, that doesn't mean the vocab from Friday changes. Our x is still our domain, our y is still our range. This is just sort of thinking about it as a value we can plug in that will give us its corresponding output. So we plug in a domain and we get out its corresponding range. And we can think about this in a lot of ways, whether it's any of the other representations we've talked about. I'm going to start by looking at a table. Okay, so maybe I'm given the function rule, y equals 3x plus 4. And I know that I have some input or x values of -3, 5, and 10. I don't know, right? Whatever numbers. We could then find what the corresponding y value is just by doing a little bit of math and plugging that -3 in for x. Okay, so instead of saying 3 times x, right, my x value is now being substituted by -3. So 3 times x becomes 3 times -3 plus 4. And realistically, I mean, I hope we could do this math in our head, but if we did it with the calculator and you needed to, fine. 3 times -3 plus 4, right, it gives us -5. So we know if our input is -3, our output is -5. Okay, if our domain is -3, a range has a -5. If our x value is -3, our y value is -5. And then we could do the same thing for any various situations. So if we wanted to do 5, instead of doing 3 times -3, right, I'm now substituting the 5 for the x. And I'm hoping you're like, yeah, Mrs. McKinney, I've done this before. This is review of a standard you already did last year, so hopefully. Right? If you're using your calculator, it's super simple. You can just arrow up and over if you're using one like mine, and you can just change that into a 5. Just delete out that negative and change the 3 into a 5. Okay, and we get out 19. And then again, right, instead of 3 times 5, now we're going to substitute 10 in for x. Now, if you really wanted to do this in your calculator and edit, it'd be a little bit more work because that above delete, it says INS. That allows you to insert something and you can type over it. But again, I hope we know 3 times 10 is 30 plus, 34. Plus 4 is 4, 34. Okay, now, just like we did last week, we could then take this information and choose to represent it as an ordered pair. So that would be fine, right? We could talk about this in any format. I just happened to pick a table to start with. Now, the step forward that we want to take with this is that we can take those function rules and we can write them in what we call function notation. So all of this, which is review from what you did before in middle school, we're now just going to add a layer to it, where in function notation, we can replace y with this symbol. Okay, this right here we read as f of x. But it's really important to understand that the f and the x are sort of just like dummy variables. You could put any other letter in there. Okay, so it could be s of t, or Q of R. It just depends on what variables are happening in the problem. So we could take this function rule up here and we could turn it into function notation simply by replacing that y with an f of x. Okay, so it now says f of x equals 3x plus 4. And function notation is just kind of convenient because it allows us to keep some things with x and y together without us having to rewrite it in these other representations. Okay, so maybe I might ask for you to calculate f of negative 2. All this is really asking you to do is to, instead of thinking about this as x equals 2, right? It's the same thing. It's saying evaluate the function f when x equals negative 2. The process is the same. We want to take this negative 2 and we want to substitute it in for x. Okay, so instead of saying 3 times x, we'll say 3 times negative 2, right? Which is negative 6 plus 4, which gives us a negative 2. The key is that when I say f of negative 2 equals negative 2, I can now see my x and y value in this same answer, right? Up here, I don't really have a way of writing it like this, so this allows me to keep my domain and my range together. So if I wanted to find maybe f of 8, right, same thing, I'm just going to this f function. I'm saying 3 times 8 plus 4, right, which will tell me that f of 8 equals 28. There really isn't anything tricky or anything else to maybe think about this in terms of difficulty level. It's just that function notation has one more nice feature, is that we can deal with multiple functions at the same time. Because the reality is, in the real world, right, you run a restaurant, you have multiple different variables you have to account for, right? You don't only make one plain cheeseburger and that's it. Okay, now, we're not quite ready to have that many variables, but I might have something like f of x equals negative x plus 11, and g of x equals x squared plus 5x. Okay, and then maybe I ask you to evaluate f of negative 6. Okay, so you would need to recognize that since we're given two functions, since this one that we're asked to evaluate has an f, the g function isn't the important one, right? We want the one that has the f in it. And so I'm going to plug this into the f function because this is the one I'm dealing with. So instead of negative x plus 11, right, I'm going to plug negative 6 in for x. That doesn't change this negative. So if I'm just directly plugging that in for x, I'm going here. Now, most of you are probably just going to say, well, couldn't I just write that as positive 6? Yes, I would hope that you would do that. And we would just say that this equals 17. Likewise, if something asked us to calculate g of negative 4, we would need to recognize that because this has a g, right, the f function is the one that's not important, and we need to plug into the g. Now here we have to pay attention to one more small detail, right? This has x happening in more than one place, which means when we plug that negative 4 in, we need to make sure we are substituting it for every single x. Okay, so we'll say negative 4 squared. Now, whatever is I'm plugging in for x, it's really important that we make sure we keep that in parentheses. Because remember when we talked about this at the start of the year, that we said something like negative 4 squared was different than negative 4 squared. This one, we actually want to square the negative 4 because that's what's going in for x. So if you're using your calculator, you need to make sure that you're putting that in parentheses. Now, if we were plugging this as a negative and there is a negative out here, then this negative would not go in parentheses because it's not part of what's in parentheses down here. Okay, so negative 4 squared is a positive 16. 5 times a negative 4 is a negative 20. So you can think about that as plus a negative 20 or minus 20, either way. And we'll get g of negative 4 equals negative 4. So one last small thing that we can look at is what happens if we have a function in notation, function rule, it doesn't matter. And we are given the domain. So we are told that the domain equals 2, 10, and 20. Okay, if you want to find the range, you will have to plug in each of those individual values. So we'll plug in 2. We will say 2 over 2 plus 1 equals 2. We will plug in 10. 10 over 2 plus 1 equals 6. We will plug in 20. 20 over 2 plus 1 is 11. Remember, when we're listing our range, we're going to put these in numerical order, and we are done.